Looking up into the night sky on a perfectly clear evening reveals the beauty of the moon and the stars, set within the deep darkness of space that is as vast and dense as it is mesmerizing. Now imagine the possibility of playing weightlessly among the stars and exploring the unknown galaxies that have captivated civilizations and scientists for centuries. A place where anything imaginable is possible. Space, the ultimate frontier. So what draws us to the limitless possibilities of space? Astrophysicist Neil deGrasse Tyson summed it up poignantly when he stated, "I think of space not as the final frontier, but as the next frontier. Not as something to be conquered, but to be explored." For nearly 60 years, the National Aeronautics and Space Administration, or NASA, has echoed the sentiments of Tyson with their bold exploration of outer space. From putting a man on the moon to landing a space rover on Mars, NASA is hard at work exploring the unknown. When you hear the word NASA, you naturally think of space exploration. But what you might not realize is how NASA and its team of scientists and professionals have changed the face of American culture. In fact, many technological advancements we now take for granted were originally developed for space exploration, but have made their way back to Earth. Have you ever worn a pair of Nike Air sneakers? Used a Black & Decker handheld vacuum cleaner to pick up a spill? Experienced a safe airplane landing on a grooved runway? If so, you can thank NASA. The technology in the handheld vacuum was originally developed by Black & Decker as a self-contained portable drill for the Apollo moon landings from 1963 to 72. The drill was equipped with a specially developed computer program, allowing it to use less power to extract samples from beneath the moon's surface. Even more impressive is the engineering of a lightweight firefighter breathing apparatus. Before 1971, firefighters carried breathing apparatus that weighed over 30 pounds. Bulky and physically grueling to carry, firefighters avoided carrying the extra weight and rushed into fiery buildings without their life-saving equipment. Engineers at NASA were able to adapt the life support systems utilized by astronauts for use by emergency personnel. Due to this change in design, the new breathing apparatus weighed a third less than the original. Furthermore, NASA was the first to test, develop, and use efficient solar power technologies. Although we are surrounded by green living initiatives in the 21st century, it was not until NASA used silicon crystals, grown in a laboratory during the early 1980s, that the green movement rallied to use the same technology in the manufacturing of solar panels. Today, because of this technology, corporations like Apple, farms and households alike can utilize solar energy to power our lives and reduce our carbon footprint. Yet some of NASA's biggest contributions to everyday life can be found in the medical field, especially in the development of artificial limbs. Development of artificial muscle systems with robotic sensing and action capabilities are currently underway for use in NASA endeavors. These developments are being adapted to create highly functional and dynamic prostheses for humans and animals. Other medical innovations include a life-saving heart pump for patients awaiting heart transplants, infrared ear thermometers, and pain-relieving LED technology. Along with NASA's influence, it is important to note that our daily lives are highly impacted by hard work and scientific exploration, both on Earth and in space. While the effects of NASA's endeavors are felt here on Earth, NASA is about to take space exploration to a whole new level, to where no human has gone before. Deep space. Deep space refers to areas beyond the Earth's atmosphere, and especially those lying beyond the Earth-Moon system. This journey to the unknown is possible through the coordinated efforts of NASA and international partners who share the same vision to extend human presence across the solar system. Deep space exploration starts with the development of the Space Launch System, an advanced heavy-lift launch vehicle that will explore the depths of space we have not yet been able to reach. The Space Launch System will allow a unique vantage point for NASA and will serve as a backup for transportation services to the International Space Station. This heavy-lift rocket is designed to carry the Orion Multi-Purpose Crew Vehicle, important cargo, equipment and science experiments to the Earth's orbit and destinations beyond. The Orion spacecraft is destined for the Red Planet, Mars. NASA's mission to Mars is nothing new. While robotic explorers have studied Mars for more than 40 years, NASA's new path for human exploration of Mars relies on the success of the Space Launch System. NASA's Space Launch System rocket will test various new capabilities, including the development of technologies astronauts will one day use to live and work on Mars, as well as return home safely. However, deep space exploration does not stop at Mars. In fact, NASA has made many remarkable discoveries through its satellite and spacecraft launches. For example, NASA's Voyager 2 spacecraft studied Neptune's largest moon, Triton. Created and designed at NASA's Jet Propulsion Laboratory in California, Voyager 2 visited Jupiter, Saturn, and Uranus before its 5-month study of Neptune. Voyager 2 was able to send back high-resolution images of Triton, but it was the orbit of Triton that astonished NASA. Unlike other moons in the universe, Triton orbits backwards. That's right, backwards. The mystery of Triton's orbit continues to intrigue NASA and raises many questions regarding why this anomaly occurs. But Triton isn't the only mysterious formation discovered by NASA. In 2008, NASA's Messenger spacecraft started to examine Mercury's surface. The closest planet to the Sun, it was discovered that Mercury's Caloris Basin extends 143 miles across the surface of the planet. Like the information sent back from Voyager 2, the images sent back from the Messenger raise compelling questions that NASA is hard at work to answer. For example, was the Caloris Basin created by inhabitants of the planet, or is there volcanic activity below the surface of Mercury? The most probable explanation is the cosmic activity of space, namely a meteorite. Much like when a rock hits a windshield, astronomists believe that a meteorite hit the surface of Mercury and ricocheted, forming the Caloris Basin. In addition to Mercury and Neptune, NASA also launched the spacecraft Galileo into orbit to examine the surface of Jupiter. As with other launches, the information returned from Galileo provided stunning images, this time of the surface of Jupiter's moon, Ganymede. It was discovered that Ganymede is covered with oceans, but these are not like oceans seen on Earth. Instead, these oceans are covered in a thick layer of ice. The freezing temperatures of the atmosphere result in a top layer of ice, but underneath the ice, scientists were astounded to discover the moon had layers of water, surrounded by additional layers of ice. While unlikely, it is undetermined if life exists within the layers of water on Ganymede. These explorations and spacecraft are just a few examples of the more recent discoveries made by NASA since its inception nearly 60 years ago. But as we can see, scientific exploration is as vast and deep as the universe itself, making NASA one of the best places to work for cutting-edge careers in aeronautics, space, and everything else in between. Of course, working at NASA can mean that you may be an astronaut. At the forefront of extremely specialized career choices, this adventurous vocation requires dedication and passion for examining the vast frontier of space. Since the end of 2015, NASA has been on the lookout for future generations of spacewalkers, pilots, and long-duration space explorers to join their prestigious team. To be an astronaut, you must have a bachelor's degree in engineering, biological science, physical science, computer science, or mathematics. Candidates must also possess 3 years of professional experience or at least 1,000 hours of pilot and command time in a jet aircraft. On top of those requirements, each candidate must pass the NASA Long-Duration Astronaut Physical. While being an astronaut presents opportunities to study the planets and outer space up close, there is a vast and diverse career path for all occupations at NASA. In fact, there are many career opportunities available that make working for NASA a unique experience. Occupations such as aerospace engineer, biologist, meteorologist, and computer engineer are in high demand at NASA. As an aerospace engineer, you may have the opportunity to design aircraft, spacecraft, satellites, and missiles. Aerospace engineers also perform research and development to see that products meet engineering principles as well as environmental challenges. You might wonder how a biologist and an aerospace engineer would be interconnected. The answer is simpler than you think. At NASA, it is very important to study what happens to the human body in space. This is where biologists come into play. As space can cause changes in the human body, the work of biologists is critical to understanding the toll exploration takes on the organs, nervous system, and other systems of the human body. For example, when astronaut Scott Kelly spent 340 days living on the International Space Station, biologists tested the effects of long durations in space on the human body. Scott Kelly's Earthbound twin brother, Mark Kelly, was studied by NASA biologists to compare the effects of space travel on human systems against his brother. While the biologists are hard at work at NASA, so are the scientists involved in various aspects of atmospheric science. Atmospheric scientists study the atmosphere of not only the Earth, but other atmospheric systems as well, such as planets or moons. Atmospheric scientists at NASA include climatologists, dynamic meteorologists, oceanographers, and atmospheric physicists and chemists. Stationed at NASA's Langley Research Center in Virginia, these scientists are hard at work acquiring data, experimenting, and examining the chemical and physical processes that occur in the atmosphere. Understanding how the atmosphere functions is vital to any and all space travel. Contributing to this understanding, climatologists study long-term weather and temperature trends. This allows scientists and engineers to develop temperature and weather-appropriate materials for NASA equipment, including the space shuttle and satellites that will orbit the Earth. Outside of these specific career paths, NASA also offers exciting support positions among technology and mathematical professionals, including budget analysts, IT specialists, and electronics technicians. These positions provide essential background support to all facets of the NASA family and contribute to the functionality of all missions, big and small. From their earliest days of discovery and innovation, to Neil Armstrong's first steps on the moon, to today's space launch system, NASA and its hard-working team of experts have reshaped not only the way we think about space, but also how future generations of explorers and innovators will help us reach further into the cosmos than ever thought possible.